Yeah, hi everyone. Very good morning to all. Really sorry. I just got some personal loss of one of my relatives, so I couldn't able to take the classes for that reason. So really sorry for that. Yeah. So to continue with from what we have left in the last class, so we are in the concept of performance tuning, and we are seeing different sections of how we will be able to tune the SQL query. And in that, we have seen about object tuning, then we discussed about fragmentations, etc. etc. So, the thing where we left out is at instance tuning. So, to start with instance tuning, basically, you know that instance is a combination of the background process as well as the memory structures. So, except small things that we have for the background process, really we don't have any control, in performing in the performance of the background process. Like, for example, there is one parameter to increase the number of database writer process, DB writer process. So, by default, it could be 2 or 3. We may increase that to 4 or 6, but not to a much higher value. So except this, really we don't have any control on the background process. But when it comes to the memory structures, yes, we do have a lot of control on that because we will be able to either increase the size of the memory or decrease the size of the memory. So we can do a lot of permutations and combinations with that. And we also know that starting from 11G, we have a specific memory component called memory underscore target. So which is going to be managed both PGA and SGA. So once you set this parameter, really we don't require to worry about uh, managing the memory structures, but still in some environments there could be a chance that we might land up in memory issues. So to avoid such things or to really see whether our database or whether the memory whatever we have allocated is sufficient or not, then we'll be able to use a query or use a view called v dollar memory target advice. So that is going to help us in order to check whether the existing memory is sufficient for the database or not. So let us go and see that now, how we can check that. So this is the view which I am talking about, v dollar memory underscore target underscore advice. So this is going to tell you uh, whether the things are okay or not. So let us go and see that. So basically we need to query 4 columns out of this view. Okay, it's fine. So as of now, there is no data because it would be reason that the database is not running since long time. So and this is just a test database. So I will show you. Apart from this view, there is another way to get the information. So that is from the AWR report. So when we discuss about that AWR report, I will show you, the similar output, whatever we have, it would be there. Then in 9A and all, we used to have something called keep and recycle caches. So really, we are not using that now, but still that concept is there. So the purpose is basically we have something called keep cache. So the name itself is telling you it is a cache. That means it is a memory, and it is keep. So in the sense, in this memory area, if you put some table data, then generally we know that database buffer cache will follow LRU algorithm, and the older data will be flushed out from the memory. But with this keep cache, the data will not get flushed out from the memory. Instead, it will be there in the cache itself, or it will be there in the memory itself. So, if any frequently accessed table is there, so it is an advantage for us to keep those tables in this keep cache. Suppose you are frequently accessing the EMP table. So you can simply put the EMP table in this keep cache so that the data will not be flushed out, and every time you don't require to perform an IO to bring the data back. So this is mainly because, as I said, this was there in 9i and all. So during that time, the RAM size is very less. I mean, when compared to the database sizes and all. So we used to use very less RAM size during that time. But nowadays, if you take, in the home desktop or laptop itself, we are going with 8 GB and 16 GB. So obviously in servers, minimum it will start with 32 GB or 64 GB. So nowadays, because memory is not a problem, we are really not concentrating on using this keep cache. But the concept is there still, even in 12C as well. You will be able to use this keep cache. So when you enable keep cache, a separate memory component will be created. So just like your database buffer cache, in the architecture you will get a separate memory component called keep cache, and how much size you want to dedicate for it, you can mention that with this parameter. For example, here we are going with 50 MB. So of course it is very small, but it is just like that. And if you want to make one table to go into keep cache, so just you need to run this alter command. So you need to say alter table name storage buffer pool keep, so that now Oracle will understand that this table need to go to keep cache instead of the regular database buffer cache. And just like keep cache, we have something called recycle cache as well. So recycle cache is something like the data will be it is also like a memory component, but the data in this recycle cache will flush out immediately rather than following the LRU algorithm. So let me try to just explain this. So suppose this is the normal database buffer cache. So usually what happens, the data will be copied from the data files to the buffer cache at MRUN, and slowly based on the LRU algorithm, the data will come down to LRUN, and from there the data will be flushed out from the memory. So this is what usually happens in normal database buffer cache. So the same thing if you go with keep cache. So the data will be the data will be copied onto this keep cache, and it will be stored in keep cache, and it doesn't follow any LRU algorithm, which means the data will be there here, uh, you know, permanently. So coming to recycle cache, so here what happens is the data will be copied into the recycle cache, and once this data has been given to the user, then immediately the data will be flushed out from the memory. So basic difference between the normal buffer cache and recycle cache is here it will wait, the data will wait for some time till it mark it as a LRU, like till the data is least recently used. So the data will wait to get flushed out from the memory. But here in the recycle cache, immediately the data was given to the user, immediately the data will be flushed out from the memory. So you don't want to store the data anymore in the memory. For such kind of tables or for such kind of data, you may use this recycle cache. So this is the primary difference between the normal and the keep recycle caches. And also coming to one more point, suppose if my keep cache is full, already I mentioned some tables need to be there in keep cache. So already my keep cache is full. So let's say four tables in total occupied the keep cache. Now I want to add fifth table to recycle cache. Sorry, keep cache. So in such case, first of all, I need to increase the size of keep cache, because keep as I said, four tables already occupied the entire keep cache. Now we cannot accommodate the fifth table into that. So in order to accommodate fifth table, first we need to increase the size of keep cache. Then we can go ahead and accommodate the fifth table as well.
So Pawan, when you say four tables, the all the data or the data that we select,
All the data. I mean, not
four
all the
table.
data. The data that you select basically. So if you select
Okay.
four columns, those four columns data will be there.
Okay, got it.
So this is the recommendation what we have from Oracle. So frequently used tables should be placed in keep cache, whereas the tables which are performing full scan, though those need to be placed in recycle cache. But as I said, in the latest versions being the we have huge memory sizes, so really we are not going to use this keep and recycle caches now.
So Pawan, one more thing, the keep cache, you are not going to flush it out. Suppose, like as you said, at the fifth table. So then you decide, okay, I instead of fourth table, I want to put fifth table.
Okay. The disadvantage, or I don't see it as a disadvantage, but the problem here is once you have some table in the keep cache, so we don't have a specific SQL command to remove the table from the keep cache. Only possibility is you need to restart the database. So because you know
Oh,
that it is memory is volatile, so once you restart the database, this keep cache will be cleared. Then you can decide, that this table should not go to keep cache anymore.
So while adding, you can dynamically add it. So you don't have to restart, but in order to remove it, you need to restart it.
Yes, exactly.
Oh.
Okay, so any questions from anyone? Okay, sorry. That's about it. And now let's go to the next one, that is tuning a database job. Now, what it could be by mean the database job. So, database job can be lot of things. For example, in a data warehouse environment, if you look at a job can be something like which is trying to delete some data and which is trying to load some data. So basically, data warehouse environments, the it is going to maintain the archival data. So, and it will be removing the very old data, or it may not be necessary that every time delete will be there. So every time it will try to load the data into the data warehouse database through some jobs, like through some tools like Informatica and all. So when they are executing, they will be executing this in multiple tables at a time. So they would be what I say, they would be taking the information from some other source database or some files or whatever, and based on that they are going to load the data to the database. So when they do that, sometimes they may report you that there is a performance issue. So how they do that is either with the help of a PLSQL program. They might write some PLSQL code to load the data, or they might execute some procedure or a package. So when they do that, basically this involves either it is a package or procedure or PLSQL program. It involves basically a combination of select, DML, and detail statements. So when somebody says that their job is running slow, as a DBA, then we need to check for the the execution plan and all. So like in the beginning for select statement, how we have generated the execution plan, in the same way we need to generate the execution plan, and if possible you can run the SQL tuning advisor as well. And to speed up the job, sometimes or many a times you might require to create the indexes. So it might happen in different sections. So let me just put it in a way. So let's say you are executing a job and the job is selecting the data from some tables. Then it is performing a load on other tables. Like the source can be a different database, and the destination can be a different database as well. So it is selecting the data from different tables in different databases, and then it is performing an insert into a particular table. And after that, it might be performing some DDL statements as well on this particular table. So let's say this is what the job is doing. Now, the performance issues could be at different levels. For example, if the select itself is taking more time, then we need to analyze why the select is taking more time. Or if insert is taking more time, we need to analyze why insert is taking more time. Or if the detail statement like alter table and all is taking more time, then we need to analyze why it is taking more time. But basically, if the select statement is slow, after generating the explain plan, as I said, we might go and apply a different profile by the recommendation of tuning advisor, or Most of the times it will be something like you need to create an index on the table. So suppose I'm selecting the data from some table called T1, and that is taking more time, then we might need to consider in creating the indexes on top of that, so that it will speed up the select statement. Similarly, when you are inserting bulk data, so similarly, when you are inserting bulk data into the table, indexes will create an issue, because when you are loading some data, let's say into a table which is having four indexes, index 1, 2, 3, 4. So what happens is the moment you insert one row into the table, the corresponding four indexes will get reflected, because when you are inserting new data into the table, obviously new data will be inserted into your index as well. So how many indexes you have on the table, and when you are performing a DML operation, that much slowness will be there. So basically, when you are loading the data or inserting the data, what is recommended is to disable these indexes so that your insert will perform faster. So here we need to create the indexes during the select statement processing, but whereas when you are doing a bulk load, you need to disable the index, and once the insertion has been completed, then you can enable the index back. So that is also one recommendation what we can do. And also we have something called enable parallel DML. So instead of executing one insert statement, or instead of one process taking care of this insert statement, just like in data pump or when we have seen those things like having multiple parallel process. So similarly for DMLs as well, and DDLs. Both DML and DDLs are having that option that you can go with parallel option, so that multiple process will be created, and that will speed up the job. But again, for this parallel process, there should be some limitation in place. So generally, it is said that it should not cross more than half of the CPU count. Like if your number of CPUs are 32, then the parallel process should not cross more than the value of 16. So otherwise it will impact the performance again on the CPU. So this is the general recommendation that we have. And of course, as I said, you can get more recommendations from the tuning advisor, but most of the times this will be the scenario. Either you need to create new index, or you need to disable the index, or you need to enable this parallel DML. And sometimes small things also will show a bigger impact. So it is not I say like a mistake or something, but many a times I have found this in real time, that the developers will be doing this. For example, if they want to schedule a job which is trying to select the data from different tables, and it need to load the data. So what they do is they will select the data, or first they will delete the data, then they will select the data from different source tables, then they will insert the data, and any post operation they need to perform, they will perform that as well. Now here in the delete, I have observed this, that most of the people will give the statement like this. So delete from table name. So while this statement you can understand that they basically wants to delete entire data from table T1. Now the point here is if they really wants to delete entire data from table T1, delete is the worst option. Instead, you can simply go with truncate because truncate also will do the same thing. And the difference here is delete need to delete row by row, whereas truncate will do it in a bulk. And also delete will generate so many redo entries because it is a change to the database. Truncate also will generate redo entries, but not that many redo entries as the delete will do. And truncate is much more faster than the delete statement. So, you know, it is always better to have a knowledge on the application as well. So you need to communicate with your application team. You, you need to understand what they what their job is doing and how exactly it is performing and all. So in my experience, I have seen this many times that people will be using delete from the tables instead of using truncate. It is, I don't know, like whether they don't have an idea of this or whatever, but it is like that. So, and in some places where I have seen this, I have given the recommendation to go ahead with the truncate, and the job time gradually reduced by 40 minutes, something like that. So, those kind of advantages will be there. So, you need to carefully understand what is the requirement of the application team, and accordingly, you need to, help them as well in improving the performance. So, that's about tuning a database job. Now coming to tuning a database. So if somebody complains that my entire database is slow, so not one particular job or not one particular SQL query, but entire database is slow, so what we need to do? So we have a very good report called as AWR report. So earlier in 9A version and all, we used to have a stats pack report. Extended version of that will be this AWR report. So what is this AWR report is every 1 hour basically Oracle is going to take a snapshot of the database. So a snapshot in the sense what is happening at that particular moment in the database, like what SQL queries are running, what sessions are connected, etc. etc. So that information will be grabbed by Oracle itself. And it will store this information in some of the tables, and these tables will reside in sysocs table space. So if you remember the definition of sysocs table space, we told that it is a extension to the system table space which also stores the base tables, but it is used for the report generation. So what is that report is nothing but this AWR report. So once you have this information ready for every 1 hour and somebody complains that there is a performance issue between this time to this time, then you can go ahead and generate the table AWR report, and we can analyze that AWR report. So, and as I said, every 1 hour this report will be generated. So for one day it will be 24 reports. Like that it will store for 7 days. And we have always a flexibility to change these values. Like instead of every 1 hour, if you want to generate it every half an hour, you can do that. For example, here you can see this is a command to change the interval. So here we are changing this to an interval of 15 days, 15 minutes, as well as the retention we are increasing to this is in minutes. So we are increasing from 7 days to 30 days. So for production environments, it is recommended to have these values, like the interval should be 15 minutes and the uh, retention period, we call that as a retention period. So retention period should be of 30 days, 30 or 35 days, whatever. So first we will see how to generate this AWR report. Then we will see some real-time AWR reports, what we have and how to analyze them. So to generate an AWR report, it's very simple. You need to execute one script. So the moment you execute it, uh, in 11G or till 11G, you will be seeing only these two options. One is HTML and the second one is text format of AWR report. So, which means you have two different formats. Either you can go for text format or you can go for HTML format. Starting from 12C, Oracle has given one more option, that is active HTML. So when you say active HTML, it is like along with the timelines what you have specified, it will take the information what is exactly happening right now in the database. So Oracle will take all this information. By default, it will go to HTML so that it will be easy in formatting, and for us also it will be easy to understand. So let's go with that. So as I said, it will ask you for how many days you want to generate the report. So let's say I want to generate for last 7 days, and these are the snapshots that we have. So because our database is down prior to today, so that's the reason those snapshots are generated after 6th October. So let me go ahead and take the report. So here it will give you the date and time, and these are called as snap IDs. So for every 1 hour when it is taking the report, it is going to generate those snap IDs, and here it will ask you the begin snap ID, means you need to provide the begin date and time. So let me take this as begin date and time, and let me take this 75 as the end time. So if you want to give some name to your report, you can give that name, or otherwise by default it will go with this particular name. And where this report will be generated, it will be generated in your present working directory. Okay, so report has been generated. Now in putty, obviously we cannot be able to read that report. So we need to copy this to our local desktop with the help of WinSCP. So let me do that. So I just copy it to my desktop. So this is how your AWR report will look like, and it will have different sections with it. So initially in the top, it will give you the details about the database, like what is your database name and how many CPUs are there, no, etc., etc. How, what is the memory that is allocated, all that information. So here you can see this is the database name, then etc., etc. What is the version and all, and this is the host details on which machine it is built, and I mean server name, and then what is the operating system name, how many CPUs are there, and how much is the memory. So all that information. Then it talks about something called ADDM findings. We will come back to this. So coming to the load profile. So this is one section where you need to concentrate on the analyzation. So here basically it is going to show you the details, how much redo size is getting generated, and how many logical reads are happening and how many physical reads are happening. So logical read means you are getting the data from the buffer cache. Physical read means you are getting the data from the database. Now, obviously, the requirement or the expectation is logical read should be more than physical read, because you know physical read will perform an IO which is not good for the database. But of course, in all the cases, we cannot completely avoid going with physical read. So definitely, in some cases, we require that. But still, comparatively, logical reads should be higher than the physical reads. And here, one more thing that we need to remember is just by comparing the values, don't come to a conclusion that the database is fine. So, for example, here in this report, if you have a look, the total logical reads that are happening is 1749, and total physical reads that are happening is 18. So when you compare these two values, 1749 is to 18, then obviously 18 is very less value, then okay, we can manage the things. Now let's say for one database, if you have identified something like this. So this is the logical read count, and physical read count you have found something like this. So here it is, a logical read count is 18,42,567, but whereas the physical reads is 7,840. Now when you compare these two, obviously 7,840 is very less value before 18 lakhs. But individually, if you see, 7,840 physical read means 7,840 IOs are happening in the database. So which is definitely a higher value, and you need to concentrate on understanding why physical reads are happening more in the database. So what I mean to say is, don't just compare and leave the value. If you feel that the value is really high, then you can go ahead and see why it is high and which tables are causing it. So that analysis also should be done by us. Then it talks about instance efficiency percentages, like how much your buffer cache is you know doing, how your library cache is performing, how your shade pool is performing. So this section will talk about all those details. So for example, here we have something called buffer hit percentage, which is 99.37. So which means if 100 statements are hitting the database, out of them 99 statements are getting the data from the buffer cache itself. That means logical read. And similarly, we have buffer no wait. So what is mean by buffer no wait? Suppose some statement hits the database and it wants to copy the data to the buffer cache. Then without waiting, it is getting the space from the buffer cache. So which means, let me try to explain this. So let's say you have started your database very fresh. So nothing will be there in the buffer cache. So let's say after that multiple queries were executed and your buffer cache is full. So now the situation of your buffer cache is like this. At this moment, one query hit the database and now server process wants to copy the data into the buffer cache. Because there is no space available in the buffer cache, what Oracle need to do? Oracle need to flush the least recently used data first, then space will be created on the top, like some space will be created here on the top. So then you will copy the blocks onto this top position. So this flushing, then this space creation, and then copying the data will take some time. Not much time, I mean to say, maybe 2 seconds or 3 seconds like that. So even the 2 or 3 seconds is also a problem for the database. So whether immediately the statements are getting the buffer cache space or not will be decided by this buffer no wait percentage. So here it is showing as 100 percentage, which means if 100 statements hit the database, all the 100 statements are able to get the buffer cache space without waiting. Similarly for redo entries. So in log buffer cache, whether you are getting the space immediately allocated or not will be decided by another parameter called redo no wait. So like this, each and every component is having the things here, and here it is mentioned the target should be 100%, but sometimes you might see some values like 70 percentage or below 70 percentage as well. But that is fine until unless your database is running fine. No need to worry about those target of 100 percentage. So the main section that we need to concentrate in AWR report is this top 10 foreground events. So this will tell you what are all the events which are causing the issue. Event in the sense the activity. So whatever the activity is happening in the database, so which activity is causing the impact of the performance will be decided by this particular area. And this is where we will get to know which SQL query or which user is causing the issue. So now, so if you have a look at here, we have some columns like weights. So then total wait time is there, average wait time is there, etc. So here, if you look at more number of waits, 81,916 waits are there for a event called DB file sequential read. And because of that, 106 seconds of total wait time was there. And of course, it has impacted 21 percentage of the database time. So, which means, so there is this event called DB file sequential read, which is causing the issue. So we can understand, from this particular thing. Now, what is this DB file sequential read? You can just go to Google and you can search for it. There will be, hundreds of wait events. So each and every wait event will have its own thing. So here, if you look at it, says DB file sequential read signifies that the user process is reading the buffers into the buffer cache and is waiting for a physical IO call to return. Or this line is more important. A sequential read is usually a single block read, which means suppose you are selecting the data from a table and the table is having 100 blocks. So all the 100 blocks will not be read into database at the same time. Instead, server process will read one by one. It will read only one block at a time, because as it is mentioned here, sequential read is a single block activity. Now for 100 blocks, it need to perform 100 IOs, and you know already, whenever the IO increases, the performance will be degraded. So that is about the DB file sequential read. Now what is the solution for this? The solution for this would be to check about the indexes. So whether indexes are there or not, because index will reduce the number of accessibility, I mean the number of blocks. So instead of 100 blocks, if you are using index, you might read only 50 blocks. So that possibility, we need to go ahead and check that one. So how we will get to know, like which table is causing the issue and all. I will show you that. So for example, here it is showing that this wait event is causing the issue and it is under the class of IO. So if you scroll a little bit down, then you will see some section called SQL statistics. When you click on this SQL statistics, it will tell you what are all the SQL statements that are executing during this time, and they are ordered by elapsed time. So ordered in the sense how we will be doing order by clause, ascending and descending. So similarly, it happens here as well. So what we look at is user IO. So click on this third one, IO wait time. So which statements are causing the wait event? I mean IO waits. So those statements will be displayed here. So for example, this is the SQL statement which is there at the top, causing so much of issue. And also there is another statement, even you can look at the elapsed time. So 16.88 seconds is one statement and 78.08 is another statement. So this statement is also causing the issue with the IO. So we need to go ahead and check what are these statements, and if there is any table is there, then we need to check, we need to ask the application team to check for the indexes on those tables. So basically, we'll be taking the SQL statement. So just if you click it, it will take you to here. So what you need to do is you need to copy and paste this and put down in an email to your application team and tell them to verify whether indexes are there or not, etc. So that is what basically we do with this foreground events. So similarly, next if you see some other wait event, accordingly you need to react to that. So what is that wait event, what it will do, why it will occur, and what is the solution, you will get it from Google itself. So more about how we can analyze the AWR reports. There are lot many videos in YouTube as well, so you can just go through them. Very good videos are available, and I have given some links here where they will help you in order to understand the analyzation of AWR report. So let me show you one AWR report through which you will be able to understand more clearly how in real time we are going to resolve these issues. And performance issues are also, especially when it comes to the AWR thing, the impact will be in different ways. For example, uh, when the I/O is increased, there are the server process is performing more number of I/Os. Automatically, that will be having impact on the CPU as well as the memory as also, because to perform more number of I/Os, more memory is required, or more CPU is required. So these three are always directly proportional. Memory, I/O, and CPU are directly proportional to each other. So suppose if memory utilization is more, automatically the CPU utilization and I/O utilization also will be high. Or if CPU utilization is high, automatically memory and I/O will be high. Or if I/O is high, the rest of the other two will be high. So always these three are proportional to each other. So we need to carefully go ahead and understand what exactly could be the issue. So this is one old AWR report which is of 10G version, but this is almost same sections will be there. So here also, some changes were there. So earlier we used to have only 5 events, but now in the latest AWR report, now you have top 10 events. So like this, small differences are there, but main criteria or main sections were remain same. So here, if you look at, there are again different weight events, and here there are the most weight event that you can see. So as per the time, if you look at, CPU time is the highest one, and even percentage wise also it is showing that 55 percentage of impact is there on the database CPU. Now the second one which is causing issue is another wait event which is having again a higher value of average wait time, and it is also causing 40 percentage of the issue. So here you can see this wait event. We have something called arc wait on send request queue. So we can try to understand what exactly is this. So you can go through this one, but basically this wait event will occur because of a data guard environment. So in data guard environment, basically one database archive log need to transfer to another database. So till that archive log transfers to other database, the first database will wait for some time, and that wait event is nothing but this arc wait on send request. So because of that, there is an impact on the network as well as the CPU, and that is causing the overall performance issue. So that means if there is a network issue between two databases, even that will cause the impact for us. So like that, we have an issue. Let me search for one more report. Okay, so this is another report what we have. So here also, if you look at so for any AWR report, you can directly come down to this top events. So here itself, you will get to know most of the details. So for example, here if you look at total wait time is now altogether 18,000. So it is showing very higher value, like in thousands it is showing, and the impact is 97 percentage, and the event is DB CPU. So CPU is tweaking very high, so at a 97 percentage. But what exactly is that causing the issue? So the one which is causing the issue could be this one. I'm not guaranteeing that, but it could be this one because high number of waits are there. Now what is this wait event? SQL net message to client. Now what is this event means? So sometimes what happens is user will be connected from some other area, like let's say I'm connecting to one database which is there in abroad countries, and I'm connecting from India. So after connecting to the database, I queried something and I am grabbing the data. Maybe what it need to do. Sorry, sorry. So once the query has been fired, once the data has been processed in the database, which is sitting in abroad region, the data need to be transferred over the network to my local machine. So which means that your database is pushing the data over the network to the client machine. So that if the network is not good, so that might create a issue, and that is what is showing here. So SQL net message to client means whatever the data that is generated in the database is being sent to the client machine, but the data sending is happening slow because of the network. So then we need to work with the network administrator to check what is the reason for this, and how we can avoid this and all those things. And which SQL statements are causing the issue? If you want to know that, again you can come down to this SQL statistics, click on that. It will tell you the details. What are all the SQL statements which are causing the issue? So for example, here if you see 100% CPU is happening for one statement. So you can give this statement to your application team stating that CPU is impacted by this. Or another query, So many queries are in more than 90 percentage here. If you see, this is 98 percentage, this is 99 percentage, last one is 96 percentage. So you need to just go ahead and tell them that we need to go and do the checkings, like why it is taking more CPU and all. So like that, we need to analyze the AWR report. And as I said, from AWR report also you can get the memory details. So for example, here if you see, there is a section called memory statistics. So once you click on, it will give you the details. Okay, so we have something called advisory statistics. In this, it will tell you whether your current PGA is sufficient or not, or whether your current SGA is sufficient or not, or if you are using memory target, whether it is sufficient or not. Okay, so this is the table where it is showing about the PGA details. So wherever here you are seeing the value as 1.00, that is your current value. So for example, right now your PGA size is allocated as 3 GB, and which is having the factor of 1. Now what you need to do is, okay, if I increase my, next thing is, if I increase my PGA to 3.5 GB on an average, then what is the impact? So already your PGA, when it is 3 GB, the cache hit percentage is 100%. So means 100% your PGA is being utilized. So even if you increase to 3.5 GB, that 100% is remaining same. Or even if you increase that to 24 GB also, the impact is remaining same. So there is no improvement in the performance. So which means your current PGA memory allocation is fine. In fact, if you go down, if you reduce your PGA memory size also, you can see there is no impact. So if you reduce from 3 GB to 2.3 GB, then also it is 100 percentage. And if you reduce that to 1.5 GB also, it is same. There is no impact. So like that, we need to understand. So same thing if you come to SGA. So again, I am taking that size factor 1. So your current SGA allocation is 9 GB on an average. So if you increase your SGA value, like for example, you increase to 12 GB. So whether there is any improvement in the performance, little bit improvement is there. So here you are seeing 41 lakhs or 41 crores something. So here you are seeing 46. And if you increase to much more higher value like 18%, 18 GB, then it will come down to 28, some value over there. So like this also, we'll be able to get the SGA values. So basically by increasing the SGA, your physical leads and all going to come down. So you need to concentrate on that one. So here if you look at the moment you gradually increase your SGA size, the number of estimated physical leads are coming down. the value is coming down, so which is good for the database. So that is how we can get the memory advices as well from this AWR report. So as I said, just you need to go through these documents in order to understand the details. So apart from that, we have other reports as well. Like we have something called ASH report. So if somebody complains about an issue with the existing session in the database, then you can generate this ASH report. It will give you the details about a particular session. So by default, it will give you the information for the last 15 minutes. But of course, if we want to for more time, we can get for more time as well. And to generate the ASH report, we need to execute this script. So really, we don't much use this ASH report in the real time. And last and finally, we have ADDM report. So it is also like a tuning advisor. It will give you the recommendations, based on the snapshots that are generated by AWR. So for example, if we execute this, so it will ask you for the begin and end snap ID. So let's say I am taking the same values as AWR report earlier. So ADDM will be a text for based report. There is no HTML format. So here if you look at, you will be having the findings and the recommendations. So for example, here if you see, it is saying finding number 1 is 25.94 percentage is impacting. Like in the database, out of 100 percentage, 25 percentage is impacting because of what? Because of user IO. So here it is saying that waits for IO to the temporary table spaces are not consuming any significant time and so, and there is no recommendation as well. So we can just ignore that one and all. So if there is any particular SQL statement which is causing the issue, it will give you the things like this. It is saying so and so package is causing the issue and you need to tune that particular thing. Or if any SQL statements are causing the issue, it will give you that particular SQL ID. So you need to check on that SQL ID why it is taking more time and all. Let me show you some sample report here. So this is one sample thing what we got from the you know some database. So the first finding is saying 100% of the database activity is impacting. Means your entire database is behaving bad because of this event. And what is that event? IO throughput. So means IO is more or something like that. So what recommendation here it is saying? Recommendation number 1. It is saying consider increasing the throughput of IO subsystem. Oracle's recommended solution is to stripe all the data files using the same methodology. You may also need to increase the number of disks for better performance. So if you remember, this is nothing but OFA. So in OFA also we tell the same. We tell that we need to have the data files spread across multiple disks, and we need to have multiple disks added to the database. So the same thing is being told by the ADDM report as well. Then recommendation number 2. It is saying consider slow down RMN or data pump activity or schedule these jobs when the activity is lower. And it is saying that 29% of your database time is taken by the data pump activity, which means during the same time when the database or when this report is generated, maybe a data pump job is also running. So we know that the backup jobs need to be executed during the night time of the server. But maybe that job is taking more time and it is crossing the business hours and all. So we need to really go ahead and change the time of this job, or we need to see why during the time that data pump job is running. Or if it is a RMN job also, we need to go ahead and change the timings of that particular RMN job. And also it is talking the same thing again. It is asking to stripe the files over multiple disks, and then it talks about the memory as well. So it is saying that the current value of your memory target is 500 MB, and it is saying that if you increase this memory target value to 875 MB, we will get a better performance from the memory point of view. So like this, ADDM report will give different recommendations based on the analysis that it will do. And most of the times, 90% of the times, these recommendations will work. So which means even a person who don't know about performance tuning can be able to tune the database with the help of these ADDM findings or ADDM recommendations. So that is all about what we have with ADDM and performance tuning as well. So anyone having questions?
Which are the most events we need to concentrate on this AWR?
Yes, exactly. So, I mean, if you are facing problem with entire database, then yes, we need to go ahead with AWR and we need to concentrate on those wait events. But as I said, along with the AWR, you can go ahead and generate this ADDM report, which will give you the direct recommendations.